students, I hope you are all fine. Today is your 9th online class of class 9 Federal Board. Subject is chemistry. Today we will discuss defects in Rutherford atomic model and Bohr's atomic theory. Learning object of this lecture: at the end of this lecture you will be able to understand defects of Rutherford's atomic model, Bohr's atomic theory, how Bohr leaped over Rutherford defects, and Bohr's atomic structure. Let's overview the Rutherford atomic model. After the Goldfield experiment, Rutherford proposed the planetary model of an atom. Just like the solar system, the nucleus lies in the center of the atom. An electron revolves around it in the orbit. Rutherford model of an atom was not completely correct. It has following defects. The revolution of the electron in a circular orbit is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Similarly, if electron moving fast in a circular path, then it will also lose energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. If this were so, the atom should be highly unstable and hence matter would not exist in the form that we know. If revolving electron emits energy continuously, it should form a continuous spectrum for an atom, but a line spectrum is obtained. Bohr formulated new explanation and a new theory to remove defects from the Rutherford atomic model. Niels Bohr, a Danish physicist, studied in Rutherford laboratory since 1912. He successfully explained the spectrum of hydrogen atom and presented Bohr's atomic model. He was awarded Nobel Prize in 1922. Bohr's atomic theory. The postulates of Bohr atomic theory are as follows. Electrons revolve around the nucleus in definite energy levels called orbit or shells in an atom without radiating energy. As long as electrons remain in a shell, it never gains or loses energy. Third, the gain or loss of energy occurs within orbits only due to jumping of electron from one energy level to another energy level. The angular momentum mvr of an electron is equal to nh upon 2 pi. The angular momentum of an orbit depends upon its quantum number n, and it is integer multiple of the factor h upon 2 pi. That is, mvr is equals to nh upon 2 pi, where n is equals to 1, 2, 3, 4, etc. Fifth, the energy of the light emitted is exactly equal to the difference between the energies of the orbit. That is, delta E is equals to E2 minus E1, where delta E is the energy difference between any two orbits with energies E1 and E2. Now, I am going to give you some home assignment. Do self-assessment exercise 2.1. Review question number 5 and 8. So, that's